Hi Jill.
Hi Jack. What homework module are we going to explore?
I want to start at beginning a solution from scratch, and declaring variables in the program's namespace.
Wow, that sounds complicated, Jack.
In the other homework modules we learned how to design a board game background picture, and some of theory behind computer coding.
I liked the idea of a snakes and ladders game. Can we make that one?
Well, let's start with the compiler, the program we write the program in. When we are not at school and want to write a program to run on our home PC, we need to download and install the free version of Visual Basic from the official Microsoft website.
There is online help if you need it, with tutorials and examples.
A program is known as a solution in computer speak. We start the compiler and are presented with the Start page. Click the New Project option on the left in the list under Start.
That bit sounds easy.
We have the option to change the name from Project 1 to Snakes and Ladders. Then we OK that and an empty project is created and we are in the designer, with a small gray box visible in the workspace, on the screen. This is our project's form. To work on the form we need 3 tool windows to be visible at the edge of the workspace.
Firstly, on the left we need the toolbox. There is a label tag attached to the toolbox window. The normal position is closed. If you click the bar to the left of the name tag, the toolbox pops out from the edge of our workspace. At the top of the toolbox window we have the name on the left and 3 icons on the right. A down arrow which displays a drop-down list. A drawing pin, which if you click it will stop the window hiding itself. The third icon is a cross and this closes the toolbox window.
To open these 3 windows, click View on the bar at the top and select Toolbox, Solution Explorer, and Properties window.
As an alternative you could hold down the Control and Alternative keys while pressing the X for the toolbox, Control and Alternative keys and press L for the Solution Explorer, but for the Properties window just press F4 on the keyboard.
Pin the Properties window to the workspace whilst you change our form. Click the form to select it, then import the background image we drew in our Paint program from the Pictures folder. Set the background image layout to stretch, and resize the form to 1278 by 800 pixels. From the toolbox we add all the picture boxes, buttons, and labels to the form that we need, and a timer. Then arrange them on the form.
You should have a button in the top right corner. We can add a picture of an exit button or just change the text to read exit or quit. Click this button and the code editor window opens and type in me close. When we run the program, by clicking the green arrow, labeled Start, if we click the quit button, this short piece of code shuts down all processes that are running and closes the program.
That is very useful if we run the program code and it does something unintended, like getting stuck in an endless loop.
First we have to make a list of what our game program's variables do, then we have to make up names for our variables that we use in the program.
My list has 2 players counters, 2 players scores, 2 dice scores, a variable for whose turn it is to roll the dice and move their counter. We need the counters across and down values at the start and home squares, and the across and down values of each square that has a snake or a ladder in it. Our code is split up into a series of loops that control the counter's movement along a section of the board, so we need the across and down values of the squares where the counter changes direction and passes under the control of the next code loop. We also need to know the width and height of a square in pixels, as these are the values that we will add to the counter's across or down values, to make it move around the board, 1 square at a time, and we may want to add sound effects or background music, or play both at the same time.
Let's start with whose turn it is and hold this value in an integer that we shall call iTurn.
We declare variables in the program's namespace. If the code is not visible on the screen, then click on the form and the code window opens. You can swap back and forth by clicking the tabs at the top of the workspace that are labeled Form 1 Design and Form 1 VB. If you position your cursor at the top after public class Snakes and Ladders, and press the return key a few times, you make a space at the top of your program code. This is the namespace where you declare the variables.
We type in dim iTurn as integer and press the return key. When we start a new game, we will have to reset all our variables to their default values. We do this in a subroutine. When you clicked the form and the code window appeared, the form's load sub was at the top of the window. Move your cursor to the last line in the block, and place the cursor at the end of the words end sub, and press the return key. Type in the next line. Private sub setup. Then press return again and the words end sub appears below on another line. All the code we write that resets our variables has to go between these two statements. So add the code I_turn equals 0 in the space between the two statements. Then in the forms load sub we add call setup, followed by open and closed brackets. When we run the code, program execution passes from the form load to the setup module and sets the values of our variables. Then execution passes back to the forms load sub.
We need to declare more variables in the namespace and set their values in setup. In the namespace after I_turn add a comma and a space in I_direction. In our setup sub, we add a space and a colon, that's two dots one over the other, after the 0, and type in I_direction equals 0. We do the same with I_level, and I_tick. With I_die, open brackets, 2, closed brackets in the namespace, but in setup we have to write, I_die open bracket 0, closed brackets, equals 0, colon, I_die open brackets, 1, closed brackets equals 0. And again we do the same with I_0 and I_1, and we declare ACR and DWN, 0 and 1 in the namespace.
But in setup we have to give them the values of the start squares across and down values. To play sounds we need a file path that points to a folder on your computer that has sound files in it, like your music folder. In the namespace we start a new line and type dimfp as string, equals quotation marks, c:\mymusic \.
If we want to play background music at the same time as sound effects, we need to place a Windows Media Player from the toolbox onto the form in the Design tab. Online help will explain how to get the player into the toolbox if it is not already there. Then click the Form 1VB tab to get back into the code window. In the namespace type dimmp as new Windows Media Player. In the form load sub add a space and colon after call setup, another space, then my.computer.audio.play, open brackets, fp space and the in character, space, quotation marks, then the name of a wave type music file that is in your music folder, add a full stop and WAV, quotation marks, comma, audio play mode repeat, closed brackets.
It may be a wise move to add a button to stop and start the music, as it could be irritating after a while, or change the audio play mode to background to play the music only once.
If we want to play a sound effect at the same time as the music, we can use the media player to do this. Just add mp.url equals fp, the in character, space quotation marks, then the name of the sound clip, and as before, .wav quotation marks.
Open the design window and click on the timer that you placed on the form. The code window opens and a sub called private sub, timer 1 tick, by val sender as system object, by val e as system event args handles timer 1 tick. The default value of a timer's click is 100. This means that every 100th of a second the program checks the code we add to the timer and takes action when it is instructed to do so. To animate our dice and counters we use a select case. Cases equals and select statement. We use the variable I_tick. We type in select case I_tick, then press return. The statement and select appears on another line. Press the return key, and on the next line above the end sub and select statement, we type I_tick plus equals 1. Now every time the timer tick event happens, the code checks if the value of I_tick matches a cases equals statement that we place between the select case and select statements, and carries out the instruction that is in the cases code line.
By changing the pictures in the dice picture box at every click of the timer, we get an animation of dice rolling. We add case is equals 0 under the select case I_tick statement, the a space then a colon then another space and I_die open brackets 1, close brackets, equals 0. This sets our second dice value to 0. I_direction equals 0. This is moving across the screen from left to right. We add the width of our square to the value of ACR0 and change the position of the picture box with the code. Picture box 1.location equals new point ACR0, comma, space, DWN0. This is in the case is equals 31 line of the timer select case statement. In the case is equals 32 line we take 1 away from our dice throw which was 1. We then check to see if die equals 0 and if it does then player 1's turn is almost over and we check to see if we have landed on a snake or a ladder. If yes then we exit this loop and alter the timer's tick value to go to the snake or ladder animation. It is now player 2's turn to roll the dice.
In the case is equals 33 statement, we check to see if we are at the end of a row and have to change direction. Again we exit this loop and execution moves to the section that moves the counter vertically. This time we deduct the height of our square from the value of DWN0, and move the picture box to the new location.
In the case is equals 34 line, we alter the value of IT to tick equals 30. The loop continues, slowly moving the counter, until one of the checks is true, and we exit this loop.
The final loop checks to see if a counter has reached home. On level 1 the game is over. On levels 2 and 3 the player has to throw an exact score, to high and the counter moves backwards. In level 3 if a counter lands on another player's counter at the end of a move then the other counter has to start all over again.
Wow, that's a lot of stuff to get my head around. I think I will take a break now, if that is okay with you.
Yes, it is a lot, and we haven't exhausted all the options that our code loops could check for. But I agree, it's time to rest. I'll race you to the well at the top of the hill.